I welcome you all to data communication lecture annotation video. In this video, we will get to see the next portion of data and signal that we were discussing in the previous video. So let's begin. In this lecture, we will focus on what we call transmission impairment. So what do we mean by this term transmission impairment? Any kind of imperfection that is caused in the signal is called impairment. That is, if we say, for example, we want to send this kind of signal and we receive a different kind of signal, it is called impairment. So a practical example we will see much later on, but at this moment, these are the definitions or explanation. What do we mean by the impairment? In simple terms, the signal at the beginning of the medium is not the same as the signal at the end of the medium. That is, what is sent is not what is received. This phenomenon is called transmission impairment. There are three causes for this kind of impairments. They are attenuation, distortion, and noise. So let's move on to the details about them. Here we see the causes of impairment in this diagram: attenuation, distortion, and noise. What do you mean by attenuation? Attenuation means the loss of energy. So what I had shown you in the previous example, that is the amplitude and the distance the signal covers, and when in the input side or the sender side, the signal is quite energetic, and at the beginning it does not have any energy to loss, but in the receiver side it happens to be a flat curve and seems to have lost its amplitude and the wavelength. So this kind of energy loss, we term it as attenuation. So when a signal simple or composite travels through a medium, it loses some of its energy in overcoming the resistance of the medium. So in other words, if we try to transmit anything at any time, we will lose some energy. That is why a wire carrying electric signals get warm, if not hot, after a while. That is why the same phenomenon works for our electronic devices that we use already and that we use regularly. For example, if you use constantly your mobile phone, it gets heated because the transmission makes the medium hot. The transmission medium is your device, the mobile phone, so it gets warm due to constant use. Now, some of the electrical energy in the signal is converted to heat. To compensate for this loss, amplifiers are used to amplify the signal. Following figure shows the effect of attenuation and amplification. Now, those who have remembered from your electronics course that amplifier boosts a signal, and it helps in maintaining a specific energy level. So at the original sender at point 1, the original signal looks like this. After passing through a transmission medium at point 2, it loses the energy but maintains the kind of shape it represents. Only the amplitude is lost. When we amplify the signal, that is, give it some energy, it gets amplified and results in back in the original signal. This is what attenuation does. So if you are asked about why do we need to use the amplifier, because we need to compensate for this loss, so we need to amplify the signal to prevent attenuation. That should be your answer. I hope you get that. Now let's move on to the next topic, decibel. To show that a signal has lost or gained strength, we use the concept of decibel. Here we will see firsthand what does it mean that a signal has lost or gained strength. We use the concept of the decibel to measure the lost or gained strength. The decibel measures the relative strengths of two signals or a signal at two different points. So in the previous slide, we had to measure a kind of way to be informed that their attenuation has occurred. So we measure it by decibel. Now the decibel is negative if a signal is attenuated or it suffers from attenuation, and positive if the signal is amplified. Now we see P2 and P1. P1 and P2 are the powers of signal at points 1 and 2 respectively, and the decibel and the formula for decibel is given is such that dB, which is a symbol for decibel, is 10 into multiplication with the log of P2 divided by P1 to the base 10. We get the decibel value of a signal if it which shows us if it has gained or lost the strength. These mathematics are very important for your quiz or your midterm, so be careful about that. And here we see in this type of mathematical example, we find out if the signal has lost strength. So we have already declared if the value of decibel is negative, it has lost some strength, and if the value is positive, it has gained some strength. And that is, if the value is negative, it suffered from attenuation. If the value is positive, then it got boosted by some amplifier. So I hope you get that. This should be your kind of self study. If you have any problem regarding this maths, you should contact me. So let's move on forward. So here we see the amplification or gain of power. So I have already discussed about this, so I think you get that. But if you have any problem regarding this math, so you have to contact me, and I will repeat it throughout this course and throughout this lecture, that you, if you have any problem, you have to contact me, and you must. Now this here, we get several points, and at the last we decide if the signal has been a gain, if the signal has gained strength or lost strength from the starting point to the ending point, that is point 1 to point 4. So if you want to calculate a decibel value in order to find out if amplification or attenuation has occurred, we have to perform any specific decibel calculation with only 2 points. We cannot measure more than 2 points by the specific formula. We take two specific points, point 1 and point 2. We find out the decibel value, and then we move on to the next set of points to find their set of decibel values, and then we move on to the next pair, and so on. So this is how it works. So I hope you get that. So let's move on forward. Now, a new concept we are seeing here. Sometimes the decibel is used to measure signal power in milliwatts. What happens here is that we are introducing just a new unit to measure the signal powers. It is referred to as dBm with m as a subscript, and it is calculated as 10 log 10 p subscript n, where pm is the power in milliwatts. So in this example, we calculate the power of signal this with milliwatts of value minus 30. So this is the formula to find the milliwatts, and this is the value given right here. And then in the next line, we divide, we take this portion. I'm going to show you some calculation, so please bear it with me. In the next portion, we have log p subscript m in that is power in milliwatts, and divide that 10 by, divide this minus 30 divided by 10, we get this minus 3 value. And then we know that if we inverse the log, it turns into a power of 10. So we get this value 10 to the power minus 3 milliwatts. I think you get that. So let's move on forward. So this is a kind of similar maths example, mathematical example. So it's your self-study. So let's move on forward. Now we arrive in the next type of transmission impairment, distortion. Distortion means the signal changes its form or shape. Attenuation was the loss of energy, but distortion is the actual change in the form or shape. What we were sending, the signal changes its form entirely. Distortion occurs in a composite signal, specifically made of different frequencies. It is commonly seen in the composite signal, and which are different in frequencies. Now, each signal component has its own propagation speed through a medium and therefore its own delay in arriving at the final destination. So, due to the signal components' different frequencies, it propagates through the transmission medium in its own way, and for that reason, there is some delays in the transmission medium, and they arrive at different times in the final destination, which is the main cause for distortion. In the sender side, we are sending this signal 1, signal 2, and signal 3. The component of this composite signal, and when we receive the signal at the receiver, we get this type of component composite signal, which is very different from the sender side component signal. And when we segment the composite signal, we get these components, which are kind of different from the original components in the phase. So this type of transmission impairment, we term it as distortion. I hope you get that. Now let's move on to the next phase, noise. So what do we mean by noise? Noise is any random cause for impairment. There are several types of noise that we are seeing in this slide: thermal noise, induced noise, crosstalk, impulse noise, etc. So some of us are familiar with the land phone or TNT phone in our country. So sometimes there is some crosstalks, that is we could pick up the receiver, or pick up the receiver and find someone talking in their phone, and that phenomenon is known as crosstalk. It is somewhat familiar with us. So thermal noise is the random motion of electrons in a wire which creates an extra signal not originally sent by the transmitter. So it adds some extra signals. That is the work of the noise. And the induced noise comes from the sources such as motors and appliances. These devices act as sending antenna, and the transmission medium acts as the receiving antenna. So if we are to perform our data transmission in a close proximity with motors and some electronic appliances, it acts as the device acts as a transmission medium, and these devices acts as the sending antenna, and the transmission medium acts as the receiving antenna. So there is always a noise in the background when we try to communicate in such a close proximity. So next we see crosstalk that I have already discussed about. So crosstalk is the effect of one wire with another if it gets somehow entangled with another piece of instructions, then it causes this kind of crosstalk problem. Now the last one is impulse noise. Impulse noise is a spike, a signal with high energy in a very short time that comes from power lines, lightning, and so on. If lightning occurs while we are transmitting, at that moment, impulse noise occurs. So I hope you get that. Now let's move on further. This is the example of noise. In this figure, we are seeing that this is the transmitted signal, and we add some noise that is a signal of different proportion, and this noise together with the transmitted signal produces this composite kind of signal. So we see what is received is different from what is transmitted. So this is what is noise can do to our transmission. I hope you get that. So let's move on forward. Signal to noise ratio. Signal to noise ratio is the statistical ratio of power of the signal to the power of the noise. In decibels, it can be expressed as follows. So the signal is the statistical ratio of power of the signal to the power of the noise. So I will represent it mathematically. SNR equals to power of the signal, PSIG, power of the signal. This term represents this power of the signal, and P noise is the power of the noise. This is how we represent it mathematically, but we have to also know the decibel mathematical representation of signal to noise ratio, SNRDB, we call it that. We get a 10 with the log to the base 10 with signal to noise ratio, and I think you get that. So let's move on forward. If you have any problem, you should contact me. Now here we see this kind of signal to noise ratio. It's kind of self-explanatory, this mathematical example. So I leave you to your self-study domain. Now let's move on forward. So the values of SNR and SNR-dB for a noiseless channel. So signal to noise ratio. If there is no noise present in the channel, the value of noise power is 0. So in terms, the signal power is all in all. So the signal to noise ratio has the value of infinity. And in the SNR-dB, same value appears, though in different form or different way. But what we have to know, which is very, very important, is that ratio that we are seeing in here, we can never achieve them in real life. It is a standard or an ideal. We can never achieve this kind of ideal values. So this is this is all about today's lecture. We will start from data rate limits in the next lecture. You would get it soon enough, I hope. But what do you need to revise during this period is to go through the examples. I have not elaborated on them. If you have any questions, I will solve them in online class. So thank you for listening. Hope to see you in next class. Goodbye.